Okay, so this is the next operation, which will be establishing the overall length of the part. I have my blueprint hanging here on my digital readout arm, so I can look at my drawing. I can see that the value I'm shooting for of the overall length is 2 inches and 937 thousandths. So if you've done this correctly, the part would be still remaining within the vise, and we might do this as a different setup if you were out of time in a specific class period. I would come back in and again clean the vise jaw up, make sure my part is filed complete. I would have my solid end mill holder. In this case, I'm going to use a 1/2 inch because in this demo I'm going to do the facing operation as well. And I'm going to use the same 1/2 inch end mill for the profile to get the overall length, and then to face to get the overall thickness as well. So I'm going to calculate my spindle RPM with my formula, which is 4 times the cutting speed. In this case, the cutting speed is 300 based on the material is aluminum. So 4 times 300 is 1200 divided by the diameter of my cutter is 1/2 inch. So 1200 divided by 0.5 is 2400. That would be the very max I would run this tool at on a conventional machine. On a CNC machine, I would be able to go that faster, and actually quite a bit faster on a CNC machine. But on the conventional machine, I'm just going to run this tool at 2000 RPM. I have it again in my quill. My setup is tight. I've hammered this. It's clean and square. And what I'm going to do is I'm going to bring my table over. And down. And I don't want to bring my quill down more than a couple inches. So I'm going to bring this up to the stop. I'm going to lock the quill. And I'm going to actually bring my table up so I have a more rigid cut here. And if you remember the difference between conventional cutting and climb cutting, I'm going to make sure on a conventional machine that I will use a conventional cut, and I will not climb mill to establish this length on this profile cut. I'm going to make sure the bottom of my end mill clears the bottom of my part here. Bring the end mill kind of close. I think my lock here is locked. Feels a little tight. There we go. So this looks pretty good. I'm going to make sure I'm in high gear. I'm going to rotate my gear shift lever and rotate the spindle by hand before I turn on power. My settings look good. Release the emergency stop. Go in a forward direction all the way up to 2000. And very similar to the first cut you did on the mills to be checked out on the mill. What I have here is I have a sawed edge. So we did a minimum cleanup on this side. We used this cleaned side, this machine surface deburr to do the layout, to do the edge find, to get the hole locations. The holes are complete. The only thing now I have to do, well, there's quite a bit more actually, but I want to establish my overall length and my overall thickness. So this side is the sawed edge, and you should be able to tell visually and look and see, oh, okay, that has saw marks on it still. So I can't really measure that and get an accurate measurement because the sawed edge is not perpendicular to any of the surfaces I'm locating on. So the first thing I'm going to do is I'm going to go in and I'm going to do same thing, a minimum cleanup. Bring this over here to this, so the end mill hear it barely touch. I'm going to bring this off the part, and I'm going to go in another 20 thousandths on this table movement, bringing my material closer to my end mill. And then I'm just going to take a minimum cleanup. And I can do a climb mill spring pass just to make sure I have a good finish without adjusting further into the cutting. I can climb mill as long as I'm not taking a big heavy cut. So at this point I'm going to take my caliper, make sure they zero, repeat zero, and I can get my end mill out of the way here. And I'm going to go ahead and measure this, and this measures 2" 980. So I'm going to subtract 2.937 from 2.980. I need to move another 43 thousandths in order to get to this number, and I want to try and get as close to that number as I can. So what I'm going to do is I'm going to come over to the micrometer dial. I'm going to, without engaging the feed, I'm going to unlock the dial. I'm going to zero this. So the 0 on the dial corresponds to the mark on the index plate. I'm going to lock that by hand, and I'm not going to take my part away from my cutter. I'm going to bring my part towards my cutter, so I'm going to go in a counterclockwise direction. And I need to remove 43 thousandths. So I'm going to go ahead and remove 20 on this pass. I'm going to bring my end mill down, lock the quill lock, and I'm going to take another cut. This is the second cut after I've taken a cut and established a known length that I could calculate how much material I need to remove. I'll go ahead, climb, do a spring pass, climb cutting pass there, turn off my, and then I'm going to check again with my caliper. Okay, so that is 2" 960 thousandths. So I need to take another 23 thousandths off of here. At this point, what I would probably do is I would take off another 10 thousandths. I would bring my part closer. Actually, I'll bring it closer 15 thousandths towards me. I would bring this down, turn on my spindle. I would take another cut and then repeat the process, measure it, and I would try and leave 10 thousandths left to take my finish pass on, and I would measure each time as I go. On this first project and even throughout the lab, it's really important that you take the time and measure the part each time you take a cut. So you know you're using the micrometer dial on the machines accurately. I think on the mill it's actually a little bit, to me it's easier because it's always, well, it's 1/1000th on the lathes, like on the carriage micrometer dial. Each lathe has a different setting. Some of the settings are 5 thousandths per line. Some of the setting are, I think there's some that are 20 thousandths per line, or 2,000. So the lathes vary a little bit. On the mills, all the micrometer dials represent 1/1000th of an inch, so it's relatively easy to read. But there's other aspects to a manual machine. When you're machining, you want to make sure that you're cutting from a known distance, and the only way you really know how to do that when you're doing a cut like this is when you are measuring each time. You're moving the micrometer dial, moving the table. This is fully engaged. The backlash is taken up. micrometer dial is locked correctly and accurately to the mark, and you're reading it as you move the table. And then each time you take a cut, stop the spindle, pull the spindle up out of the way, and then measure. And if you do this, especially just on this project, on every time you take a cut, on the second mill project that we do, you're going to feel a lot more comfortable and you'll be a lot more experienced, and you will likely become more accurate, because that's the goal here, is becoming more accurate. So that would be establishing, again, the overall length at 2 inch and 937 thousandths. I'm also going to now, let's do the facing operation that establishes the 0.375 thickness of the part. Originally, I gave you material that was 1/2 inch thick, so I know I'm going to need to remove at least 100, probably more like 125 thousandths. And a lot of times in machining, I use the word probably, but when you're in industry, we don't use probably. We know exactly how much we need to take off. And we shoot for the middle number, whatever this value is. And usually we're within a hair's length. We're within 5 thousandths plus or minus. Using the machine, we're able to do that. So what I'm going to do, instead of saying probably, I'm going to go ahead and measure this thickness. And this part measures, this part's been cut already. This part measures 430 thousandths. So someone's already faced off on this particular piece of material. So what I'm going to do is I'm going to actually bring my quill stop up a little bit. I'm going to bring my quill down, use the lock. So now this isn't going to move up or down, and I'm going to be using the bottom face of my tool to face the top of the part. So for this operation, I'm going to use the same RPM. I'm going to come slightly over the part here. 2000 RPM, and my quill is locked against the quill stop here. I'm going to bring my end mill up. Look out underneath and just gently rotate my handle here until I see and hear my end mill touch the top of the part. I can pull this out and it'll release. I can bring it up and use the leverage. I can hear it. That's all I really need. I'm going to take this off the part. I'm going to loosen this micrometer dial, go to 0, and I know based on the thickness I measured, it's 430 thousandths, and I'm going to take off 55 thousandths of an inch. So I'll probably take off 20, 20, and then measure again. And again, when you're running this operation, you should measure each time you cut. So my micrometer dial on my knee, that's bringing the part up closer to the bottom of my end mill, is 0. So I'm going to go 20 thousandths. And I should face the part, and then I should measure this part at 410 thousandths thick, because I was at 430 thousandths and I moved my table up 20 thousandths. 430 thousandths minus 20 thousandths is 410 thousandths. The other thing about this particular facing operation is, if you have done these holes accurately and the countersink looks good on all of these, we actually would want to face only on the back side. So that's something that you might need to do. If you have countersunk too deep on some of these, you probably would want to face some of the material off. So when you look at it and you measure the countersink diameters, they don't measure larger than what is required on the drawing. Okay? So a lot of times if people do that by hand without using the table feed I showed you to kind of creep up on it, if you're a little too aggressive with the countersink, then the countersink might be too large and you might have to face off some of the material. In this case, I am facing off this side. I haven't moved the part. If I were only going to face material off the back side of the part to get my thickness, I would take this out. I would take my parallels out. I would clean this all as clean as I can get it, make sure my part is deburred, flip it over, and make sure I use a dead blow hammer, make sure that these parallels don't move, that I know that the top of my part is flat with the parallels, which is parallel to the vise, which is perpendicular to my spindle in both directions. So from here, I'll go ahead and take this facing roughing cut, and you could go, feet kind of aggressive on this at 2,000 RPM. And the conventional ply milling, it doesn't matter too much when you are facing, because the tool pressure is not on the side of the flute that grabs. There's more of the tool pressure spread out across the whole diameter of the tool when you face. So I can actually go both directions. So in this direction, I'm actually ply milling. And if I go in maybe 60% of the end mill or more, in this direction I would be conventional milling. And you can be a little more aggressive when you face on the feed. You can kind of feel and see the material as it's being removed. I've come off the part, I faced everything. I'm going to take my brush now and brush the material away, and then bring the table out a little bit more here and measure. And it might be good to use your micrometer on this one, but I'm going to bring the table out so it clears the front here. And I can measure this now. Make sure that my caliper is not crooked this direction or this direction. So it measures 411 thousandths. So at this point, I know I'm still shooting for that 375, and I'm going to go and leave 10 thousandths on this to face for my finish pass. So I'm going to go 15. I'll bring my table up another 25 thousandths, 10, 20, 25. I'll face this again, and then measure again. I should have at that point 10 thousandths left, and I would bring the table up again another 10 thousandths and take my finish pass. The next time I measure, or I would cut this again, I would want to measure on both sides, this side and this side. And if you look at your setup, this is a three-dimensional object. Could actually measure on all four corners of this part, because the part may have a chip if you didn't clean this accurately enough. There may be a chip underneath the parallel, or the part's not deburred correctly, and the part, instead of sitting flat, it will be tilted up this direction or this direction, and that will take off more material off the high point. So as we go, we want to measure a few different spots to make sure we're facing flat against the bottom of the part, which is flat against the top of the parallels, again, which is parallel to the bed of the vise, which is perpendicular to the spindle in both directions.